Okay, Cardano and Ferrari. We've heard of Cardano. Who's heard of Lodovico Ferrari? One person. Okay, and they really do deserve to be mentioned together. This is Cardano. This is the book he published in 1545. Now, here's his vitals. This is the city of Milan. He gained a doctorate of medicine in 1526. I don't know how, when, where he got into mathematics officially, but of course in those days a lot of mathematics was done by people whose principal activities were elsewhere. In 1536 he gained a student called Lodovico Ferrari. Now he was actually a servant, I don't know if it was just a domestic servant or a clerical servant, but he showed a lot of nous with the clerics, and Cardano started teaching mathematics. And when Cardano moved on from his university post, so Cardano was teaching mathematics at university, he arranged for Ferrari to take his position, then that was age 20. Now, they solved x cubed plus ax squared plus equals b in 1539, so that was not original. Tartaglia was the first we know of to do that, but they rediscovered it. They could not, no matter how hard they tried, they could not crack the depressed cubic. And they knew it had been done. Tartaglia boasted about it. Okay, he didn't keep it. He kept the method secret, but he didn't keep his knowledge secret. He boasted about it. So, but, a couple of twists. They learned the solution twice. First one, 1539, they learned from Tartaglia. They persuaded him to divulge it, and he gave them the result but not the method. And Cardano and Ferrari wanted to publish it. I don't know what made them exempt from the culture of competition. Maybe confidence, maybe not caring too much, who knows. But they wanted to publish it. They were ready to publish. They had the rest of their book ready to publish at this time, and they wanted to include the cubic. But Tartaglia refused, saying he was going to publish it himself. He just wouldn't commit to when. He was working on other things, and when I finished those, etc., etc. So they did publish a book in 1539, but it didn't include information on cubic. In 1543, well, what happened in the meantime is they solved the general, meaning that they found the link between the general cubic and the depressed cubic. Right? So that knowledge was original to them, but they couldn't really publish it because they couldn't provide a proof, if you like, for the depressed cubic. They couldn't provide a complete solution. They were getting desperate to publish. Guess what else happened? Ferrari solved the quartic at about the same time. I haven't seen the mathematics involved in that. I almost don't want to know. But it was about the same time. Maybe it's surprisingly simple. And so with this knowledge building, they were desperate to publish. And so what happened in 1543, they sought out Della Nave, the son-in-law, and they asked him for information on the depressed cubic. And Della Nave was not involved in mathematics, didn't have anything to hide. He showed them Del Ferro's notebooks. So they learned the full solution of the depressed cubic, and therefore the full solution of the cubic, full stop, in 1543. And they considered, and I agree with them, that released them from their obligation to Tartaglia not to publish. All right? They found that knowledge predated Tartaglia. They've now come into that knowledge. We have, the son-in-law's permission to publish. We're publishing. So in 1545, Ars Magna was published. Monumental book. The sources I've read say that in a very small time frame, Copernicus published his work. some other important person published their work, and this was published in a very short time frame. And I could only find one or two comments that mention this, but he was considered the world's leading mathematician at this time because of this book. And I guess it does stand out that someone would publish a book giving away lots of knowledge in that culture. Bombelli, haven't mentioned him at all yet. I should mention something actually about, this is about cubic equations and complex numbers. We've seen how cubic equations led to the concept of the square root of a negative number in an unavoidable way. I was talking to someone last night who echoed what everyone would think, that complex numbers came into being because we wanted to solve quadratics. It's the most logical thing to think in the world, isn't it? Right? But it's false, because there's an element of choice there. All right? To solve quadratics, to invent complex numbers in order to solve quadratics, you have to make a choice that you care about solving all quadratics. And their choice was, we don't care about solving all quadratics. We're only interested in really the solution of practical problems or maths competition type problems. They're always going to have positive solutions. Yeah, there was no need to make that choice. But with cubic equations, it was unavoidable. To get that solution of x equals 4, you had to have 2 plus this I plus 2 minus that I. Right? They didn't use the number I, they just used the square root of a negative number at a time when they weren't even using negative numbers. So Cardano dipped his toe in that water. I think Del Ferro avoided it altogether. I'd like to know more about that. It's easy to count, like x cubed minus 15x equals 4 has the obvious solution x equals 4, right? 64 minus 60 equals 4. But to get it that way, you need to go via complex numbers. Well, what did he say about that? There just seems so little actual biographical information about Del Ferro compared to Cardano. I guess that's what publishing a book does, right? And so I think Del Ferro kind of avoided that, but I don't know how he could have avoided it altogether. Cardano and Ferrari, whenever I say Cardano, I mean Cardano and Ferrari. Cardano and Ferrari dipped their toe in it. They impressively, I guess they were inspired by these complex cubic things but didn't know what to do with the square root of negative numbers in them. But it perhaps inspired them to think of a simpler example, which is a good thing to do when you're faced with something hard, isn't it? So they, in the Ars Magna, they detail the problem. Find two numbers that add to 10 and multiply to 40. And that doesn't have any real number solution, but they found that 5 plus or minus the square root of 15i ought to do it. Sorry, the square root of negative 15. So 5 plus or minus the square root of negative 15 will do it for you, right? And yeah, they said, right, well, this solves that problem. So they didn't grow up learning complex numbers. They didn't have any culture of doing it, and they didn't seek to implement them either. It was just a case of, okay, so we've got these problems where these square roots of negative numbers pop up. What do you do with those? So the key phrase that I like is, I forget the exact words, but yeah, nevertheless we shall proceed, right? So I've got these things I don't know what to do with, but if I just try to apply normal rules of calculation, then I get somewhere. That's still a long way from, because we needed to get the square root of negative 111 over 98 or something. Like I'd have trouble with pen and paper. I'd have trouble getting the solution to that. So Cardano didn't go very far down that path. So he's widely credited as being like the father of complex numbers, but that's kind of false. His achievements are wonderful. He was a pioneer of probability as well.